Hi, boys and girls. Today we're going to be doing just another calculus prep day. There's a random assortment of problems, so there's really no topic name for this. It's just some random stuff that we have to be sure that you know before next year. So the first thing, we're going to take x plus h and we're going to put it in every time we see an x. So this is going to be x plus h squared plus 3 times x plus h plus 2. Then the next part, we're just going to subtract f of x. We already know that's f of x, so x squared plus 3x plus 2. And then all over h. All right, so we squared this out. So I'm going to get x squared. Now you need to do the binomial expansion, FOIL, box method, whatever. So you get x squared plus 2xh plus h squared. Distribute here. So you get 3x plus 3h plus 2. Then subtract all that junk. So minus x squared minus 3x minus 2 all over h. So then from there, we just look to see if I can cancel anything out or combine like terms. X squared and x squared, negative x squared go away. 3x and negative 3x go away, and 2 and negative 2 go away. So now I'm left with 2xh plus h squared plus 3h all over 3. Nope, all over h, rather. So then all the h's cancel out because they have one h on bottom. That looks terrible. So we get 2x plus h plus 3. And that's it for that one. All right. Number 2 and 3 on our notes here have to do with conic sections and more importantly circles. So hopefully you recall that the equation for a circle was x minus h squared plus y minus k squared equals r squared. Well, we know our center, so that's x minus 1 squared, and y minus 2 squared equals r squared. Then I'm going to take my other point and plug it in for x and y, because that's what it is, right? X comma y. So negative 2 minus 1 squared plus negative 1 minus 2 squared equals r squared. So now we're going to solve for r. So that gives us negative 3 squared plus negative 3 squared equals r squared. Well, that's 9 and that's 9, so that means r squared, you guessed it, is 18. Now on our equation, we just have to know what r squared is. We don't have to know what the square root of r is. So that's going to be x minus 1, y minus 2 equals 18. There's our equation. We're done. Now you could do distance formula on that if you wanted. Distance formula is a little ugly. Not that we don't like it, it's just a little ugly. We don't have to necessarily just do these problems one way. Okay, number 3, it's just like when we had on our test. First thing to do is get all our x's and y's together. So x squared plus 6x. I'm leaving myself some room. Y squared minus 4y, leave myself some room, and I get negative 3. The second step was to complete the square. So we take half of 6, that's 3. 3 squared is 9. Half of negative 4 is negative 2. That squared is 4. Now be sure we add it to both sides. Add 9, add 4 to both sides. Then we factor. We finish completing the square. So that's x plus 3 squared plus y minus 2 squared equals 10. It wants to know where our center is. So our center is at negative 3 comma 2. And our radius, square root of 10. All right, one last one, and then we'll be out of here. Finding the domain of a rational function. All right, well, if we think back to when we had a rational function of 1 over x minus 2, we set the bottom equal to 0 and solve. That meant I had an asymptote at 2, which just means my picture looks like this. That means that our domain was negative infinity 2 union 2 to infinity, right? I could use everything but 2. So the same idea, the same principle is going to hold true here. If I set the bottom equal to 0, that's really the only thing I'm worried about. So I square both sides, I get x squared plus x minus 2 equals 0. Then I want to factor that, so that's going to be x plus 2, x minus 1 equals 0. Set each part now equal to 0, and we're going to have two magic numbers. They're going to be negative 2 and positive 1. All right, so if we think graphically for a second what this means, it means that at negative 2 and at positive 1, I have a parabola that kind of looks like that. So if that's hard to see, I'll go over it in red. Now it looks like the red's on fire, whatever. So this graph this graph right here, is only defined when the denominator is greater than 0. I guess that's it, actually, greater than 0, because it can't be negatives and it can't be 0. So what we did here was we found the two terms, or two numbers, when it equaled 0, and then I want to know when everything's bigger than 0. Well, if we look here on our graph, from here to here, it's bigger than 0. From here to here is bigger than 0. So what I mean by that is down here, it's negative, right? The y values are negative. So that means for our answer, we want everything from negative infinity to negative 2. And then it skips all this junk, picks back up again at 1, and goes to infinity. All right? If you didn't understand that, let me break it down real quick. Set bottom equal to 0, find the numbers, then we're using everything but those numbers and everything not in between those numbers. So, yeah. All right. Good luck, guys. We'll catch you later. Bye.